Welcome to qnawire.
We're told that we have a ship which is throwing some landing equipment. The ship is moving at a velocity v sub s of 45 centimeters a second or 0.45 meters per second. And the equipment is thrown with an initial velocity v of 0 of 15 meters per second at an angle of 60 degrees. Okay, so then our velocity then in the x direction is 15 meters per second times cosine of 60, gives us 7.5 meters per second. We do the same thing for the y except using a sine and we get 13 meters per second. So what distance d from the ship dock should the ship, or what distance d from the dock should the ship be when the equipment is thrown? So what we need to do then is we need to first find the amount of time that the equipment is going to be in the air to find the distance the box is going to go from that initial velocity. And then we can add that to the distance the ship is going to travel in that same amount of time to get our total distance here. So delta y here, since the ship is 8.75 meters above the ground, we know that it is equal to v of y multiplied by the time plus 1/2 the acceleration in the y direction, which is just going to be negative the acceleration due to gravity, times time squared. So we can rearrange this to say that, let's rewrite this here where the arrow is pointing, that minus 1/2 g times time squared, right? Because and the negative here is coming from the fact that gravity is in the negative direction, plus v of y times time minus delta y is equal to 0. Okay, so then using the quadratic formula, we find that this is equal to v of y plus or minus the square root of v of y squared plus 4 multiplied by 1/2 g. The plus comes from the fact that g again is negative, times delta y divided by g. Okay, we find that this is equal to, if we take the positive value, 3.21 seconds. Okay, so then using that time in the kinematic equation, delta x is equal to the velocity in the x direction, which we were given, times the time, which we just found, okay, which is plugging those values into that equation, we find this is equal to 24.1 meters. Okay, so that's the distance the box is going to go from the launch. Now we also want to find the distance based upon the ship here. So the distance the ship travels in that amount of time, delta xs, is equal to the velocity of the ship multiplied by that time we just found. And this is equal to 1.44 meters. So then to get the distance d, we simply add delta x to delta x sub s. We find that this comes out to equal 25.5 meters. We can box that in as our solution to the question.